You are on, pasal you are tidur balik Suara. Try je.
Has magnitude and direction.
Magnitude and acceleration. Acceleration is a application. Okay, good. Displacement. That is the application. So a vector is involving magnitude and direction. So what is magnitude? What the meaning of the magnitude? What the meaning of direction? What is magnitude? Guys, what is magnitude? What is magnitude? Try. It's okay. No, you not tested yet.
The value that
is
a value.
what?
Magnitude is a value.
A value. Okay, good. Betul. Value. We represent what? A value represent
Value is that
distance. Yes, distance between one point to one point. There is a magnitude, a distance. So how to calculate distance? Is it the distance in the negative?
the distance is between negative or positive, depend on the direction of the magnitude.
Okay, good try, but okay, no. So now we have 2 point. If we have 2 point, meaning we can have one line, right? A line. So in these 2 point, we have a distance. Okay, a distance, which is this distance always greater or equal than 0. If 0 meaning these 2 points meet at the same point, so that is 0. So always positive, meaning always positive. VE. Alright, always positive. So maybe there is 5, 3, but it cannot be. Example, maybe it's 5, 10 cm, millimeter, maybe kilometer, and so on lah. Okay, or non-example meaning not distance cannot be negative 5, cannot. No, okay. No distance negative, no negative. So that's why magnitude we denote as a modulus D. So now a vector is a mathematical quantity that has both magnitude and direction. Direction meaning we have a direction, maybe to the right, to the left. So if we have a line, so maybe there is arrow here, meaning the direction. If the arrow here, meaning this direction. If this direction, there is this. So meaning this vector have this distance, these 2 points, and the arrow. Alright, that is the vector. So the application of the vector will go to the velocity, displacement, velocity, acceleration, force, and so on. Later you will go to the that problem. So if we say that a scalar matrix, scalar, it's not a scalar matrix, sorry. If a scalar is a mathematical quantity has only a magnitude, meaning what is scalar? Scalar is just no direction. A vector which is no direction. The scalar just represent a single letter. For example, A. Example quantity, a measure. So you need to identify, is it the scalar or a vector? If a vector, usually we denote as AB and then a bar here, or A, small a, with the bar below, or A with the curly what we call this, with this notation, so maybe B, this meaning the vector, meaning we have a component, this is a component of a vector. Okay, so that's why we have a point, 2 point, and then we have a direction, so we have A, B, and then something like that, B, A, so something like that. That is the direction lah. Okay, so the magnitude of vector A, B equals to A, which is, this is A. This is A. We denoted as a, the magnitude, magnitude. So modulo. We take modulo both sides. And then we have vector negative. Vector negative meaning the vector we have a different direction. Same magnitude. The idea here is the same magnitude but the different direction. Opposite direction. Opposite. Okay? Two equal vector. What the meaning of two equal vector? Two equal vector A, B said to be equal. Okay, equal if and only if they have a same magnitude and same direction. Same magnitude, same direction. If I have a vector here, A, and then I have here, B. Is it the same if this is same magnitude, same direction? Is the same vector because just a position is not the same. So if say, so we call it as a parallel. Usually we call it as a parallel. As long as it's parallel to the A, so this is the equal vector. Make sure the same magnitude and same direction. Okay, direction of A, direction of B to same magnitude. Okay, now, okay, addition. So as usual, we have addition, multiplication, subtraction, and division of the vector. So how to add, how to subtract the two vectors? So we have this formula. So vector A plus B, so A plus B, so we get A plus B, something like this. So we have parallelogram law. So according to the parallelogram, if two vector quantity are represented by two adjacent sides or a parallelogram, then the diagonal of parallel will be equal to the resultant of these two vector. Apa ni dia cakap? Okay, for example, if we have two vector B and C, so we get we get A is okay. A, we move this. We move this here. So that's why we got this A. So A plus B, we will get this vector. So this vector is equals to, this is B. We move this the same magnitude and same direction, B. And A also we copy A. So this is A. So that's why he said parallelogram of law. We said we have a this what, this kind of the diagram, parallelogram lah. So which is satisfied this law. The sum of a number of a vector, the sum of all the given join the start first vector to the end of the last vector. So if we collect, okay, so now vector, we need to identify what is A, B, C. So the movement, okay, for example, A plus B, A plus B, so this is C. So this is C. A plus B, C. A plus B plus C plus E, so equal to D. So A plus B plus E, so equals to E. Okay, D. So A plus B plus E plus F equals to G. Okay, negative G. Sorry, negative G, because the arrow is here. So A plus B plus E plus F, negative G. So because we come from A to F. Okay.
Sorry, doctor. Why put negative G?
What happened to negative A?
Negative. Why we write negative G?
Because direction.
Oh,
Direction. If G is from A to this F, so the arrow should be here. But now the arrow should be here. So we said that A plus B plus E plus F. So meaning A from A plus B plus E plus F. So it's come from here to here. So the direction, so this we change the direction. So the magnitude is same. So we put the negative. Okay.
okay.
Subtraction of vector A minus B. So it's defined like this. So it is what? If a matrix, we cannot, there is no commutative properties here, but for the vector, there is, we can ignore about position. So A minus B equals to B minus A. But the position, you make sure position cannot, right? Cannot, because we have a direction, so we cannot. So position also important here, because we consider the director. So A minus B not equal to B minus A. For a real number it's okay, but for the vector cannot. Okay. So we have this. So actually for this diagram, we just have A, B, and then because of negative A, we change the direction but the same magnitude. We put here, this is negative A, and then B, is it B we change a negative? If we change the negative, so they will go to here. So B, negative B. Okay. So B minus A minus B, B minus A. So why this? B minus A, B minus A. B goes to here. Okay. Sure. To explain this, again. D is B minus A. So how we come with this? So we have this A, and then we have B. A, right? So now we have this negative A. We move this vector here because B, after B we minus A, meaning we plus minus B. No, this example not refer to this formula, but meaning here there is something wrong here ni. A minus B, should be A minus B here, should be B minus A here, B minus A. Okay, so we move this here to here, so meaning the same magnitude but the opposite direction, so there is minus A here. So now we have B minus A. Okay, clear? There is something wrong there. Okay, something wrong there. Not satisfied the commutative law. Succession vector does not satisfy commutative law, but the magnitude is still the same even though the direction is opposite. Magnitude is the same. So what is the meaning not satisfied? The commutative law. What the meaning of not satisfied the commutative law? Okay, apa maksud dia? One mark. One extra mark. What is the meaning of non-commutative law? Try. It's just a point for you to try. What is the meaning not satisfied? Not satisfied. The commutative law for the subtraction. Hello guys. Guys ramai ni. Hello.
Commutative law.
Ha.
Commutative law is a law that when you add or multiply number, you get the same answer if you swap the number around.
To number around. How? How again? Dot to the number. The last word.
When you add or multiply numbers, you
Okay.
get the same answer if you swap the number round.
Yeah. Betul. Meaning you not satisfied the commutative
You
law?
anything, you will get the same number.
Yes. If you add A dot B equals to B dot A. If you add A plus B, so equals to B plus A. If you say that A minus B is equals to B minus A. So no, it's not satisfied. Not satisfied. Okay, not satisfied. So not satisfied meaning A minus B is not equals to B minus A. But we know that but if we put magnitude A minus B equals to magnitude of B minus A, so equal. But for the direction not equal, not satisfied. Okay, not satisfied. Remember, they involve position. So if you wrong put position, so you get a wrong answer. Alright, so next, scalar, good try, bagus. Scalar multiplication of vector. So let K be a scalar and A represent a vector. The scalar multiplication KA is this K times that of the length AN. And apa ni? So K is a scalar multiplication lah. We want to, if we have A here, and then we have K. So we have KA. Same magnitude, same direction, but more longer. Okay. That is a K times A. So a vector those direction the same if K is positive, the opposite is direction for A if K is a negative. So positive is the same direction with the original. From original vector. Negative if opposite direction from the original. Alright. Parallel. What is parallel? Parallel meaning the same. So we have K like that lah. So maybe we said there is a parallel meaning in Malay is selari. So selari. So parallel if we have A, maybe another A may be here, but it's still a parallel because the angle here is same. The angle here is same. So this parallel. Or even this vector is more longer, so there is KA. So still we call it as a parallel. But if two vector have opposite direction, so it's not parallel. So opposite direction is not parallel. But if same direction, same direction, so it's parallel. Okay, so component of vector in term of a unit vector. So we have for r, if we say r from the origin, the terminal point r has 3 coordinates, x, y, z lah. So we have 3 coordinate vector. So we have x, y, and z. So where is the point? Maybe here. So we have a vector in this 3 dimension. Okay. Be a unit. Kalau dia kata if we say that be a unit vector, so meaning there is a 1 for each component. So for x component is 1, 0, 0. But make sure usually if we put the coordinate, we put like this 1, 0, 0. But if a vector, so it's like this. Okay, the symbol. So we know that this position, this kind of point, we have a vector. Remember, it's a normal, just a point, but this is a vector. Okay, so for 2 dimension, so we just have these 2 x, y only. So if we draw the 2 dimension, we got this. So if we say that 5i 3j, usually in this chapter we will see I, j, k, and then at all we got x, y, z. But as well as input this sekali, so meaning this is a component of a vector. So for 3-dimensional, we have this. Okay. Which is x, I, j, k. I, j, k, represent of I, j, k. You need to imagine lah. Sometimes some problem in the vector needs a kind of imagination. So need to able to imagine where is the position for the vector. Okay, a vector unit pointed in a positive direction of a x-axis is denoted by I. A unit vector pointed a positive direction of y-axis denoted by j, and similarly, a unit vector in a positive direction of z-axis is denoted by k. So example, draw. For example, draw. So we have this. If you have mapper, you can draw. If you have mapper, but I'm not sure. My mapper is not working. Not working. So mapper. But we can try. I think it's not correct in installation. So in mapper we can draw lah. Draw the vector. Okay. If I have new worksheet. Calculus lah. Oh, what should I put here? Okay. If I have 4j vector, vector, we have vector, we have no vector. How to put vector? Long time not use this. I plus 5j plus 6k. Okay, so right hand click here. Plot 3D plot 3D plot. It's complicated, ya. I return reset. How to delete? Okay, again. I want to plot a simple plot. A plot. Again. So I have 5j plus 4i plus minus 3k. Okay, so now we have this, so we want to usually before this is easy to plot, but I'm not sure. Construction maybe. But if we can select this and then we have, for example, if we have add 3k plus 4j minus k. So we solve this, and then we can collect coefficient for I, collect coefficient for this, collect we can collect or differentiate anything. We can use this. Okay, you can add, you can subtract, you can multiply. So if multiply, what we will have, so we have this. Why we have this? simplify. So we can simplify this actually. Simplify this. Okay, then we just can collect what is the, if we have a long equation, so we just use this. It's more easier. Okay, just introduction for you for Maple, how the Maple work. Okay, so now position vector. Okay, position vector meaning we have a point with a coordinate P, X, Y, Z in a position of OP, where from the original, meaning it's come from this. So we have this from original, 0. Okay, 0. So meaning R3 meaning X, Y, Z lah. X, Y and Z. Okay, R3. So 3 position. So component of X, Y, Z, they the same method, just minus for the minus. So just easy. So for example, A given this point in R3, and then AB minus, if he said AB, so meaning OB minus OA. So if we say that A is meaning this is OA, this is OB, and then OC. So we will get AB. Is 3 minus 1, 4 minus 1, 3, negative 2 minus 6, negative 8, 7 minus 3, 4. Just minus for the respective X, Y, and Z only. For Z, for Y, for X. Okay. It's similar. So X minus X1. So X1, X2, X3, Y2, Y1, Y2, Z2, Z1, sorry. Apa ni saya marut. Okay, X1, Y1, Z1 minus X2, Y2, Z2. So we will have X1 minus X2. Okay, Y1 minus Y2, Z1 minus Z2. Okay, is the formula lah. How we get this. Okay, simple. So BC. So BC, where is BC? BC, B minus C. So B minus C. BC meaning B. OB minus OC minus OP. So OC minus OB, OC, where is OC? OC is 9, 1, 5 minus OB 4, negative 2, 7. So we have 5 minus minus, so 3 minus negative 2. Okay. So magnitude of length of the vector, so magnitude or length of the vector or distance of any vector of this, so we have this. It's like magnitude lah, magnitude. We just learn for the imaginary part. Magnitude. We just put in this square root, so we get the magnitude of the vector. Okay. Each element we square, and then we add, and then we square root. And then magnitude of length a vector from point to the point Q is defined as this. Okay, for the magnitude, if we have 2 points, this is for 1 point. 1 point. So for 2 points, we need to operate first. Operate with the operation addition or subtraction, and get solution. So we get a point, so that we just put into a similar formula. Okay. You can see here. So for this, operate first. So B minus A, AB. So equals to OB minus OA. So we will have OB negative 2 minus 4, 1 minus 3, 6 minus 2. So we will have this position negative 6, negative 2, 4. Okay. And then AB bracket, take a magnitude. So square root negative 6 square plus negative 2 square plus 4 square. Okay. Then you get 56, square root 56. Okay, and then unit vector. A unit vector, we have a direction U is defined with this. Okay, we have a head, U head, and a vector here, and then the vector divided by the unit vector, which is where U head, magnitude of U head should be equals to 1. The magnitude, okay, the magnitude. Okay. What the meaning of this? Meaning A plus A square plus B square plus S. We use S, Y, Z. Okay. So meaning here, we square root X square plus Y square plus Z square, you should have 1. That is the meaning of this. Okay, unit vector. But we need to make this first. So a vector we have a line equal to 1 is called a unit vector. Normally a unit vector in a direction u is called as u hat. Okay, u hat. So given by this, so find the unit vector of a direction of u. So show that u bar, magnitude of u bar, the distance of u bar is 1. So by using this formula, unit vector. Okay, so by using this formula, we have this formula. So what is u? U is 7 I or you want to put like this, 7 3 1, and then this is u. So now I want to find u, distance of u. Distance of u 7 square plus 3 square plus 1 square. So what you will have? You will have square root of 59. So u bar equals u hat equals to 7 3 1 divide by square root of 59. Right, so if we put in the component, so 7 over square root of 59 I plus 3 square root of 59 j plus 1 over square root 59 k. So now we want to prove, so show that this is equal to 1. So we take everything here, the coefficient of I, j, k, we square root of this, and then we got 1. Okay, this exercise. So first of all, you need to find what is magnitude of u. Magnitude of u, square root of 2 square, take the coefficients, negative 1 square, so we get 4 plus 1 square root of 5. So put it inside here, so negative 2, why this will be negative? Find the unit vector in direction opposite. Okay, direction opposite, so you make sure, so u opposite of u, so negative ui minus ki. Okay, so that's why it is negative here. It's positive. Negative is positive here. Okay, it's similar here. So you need to find u first. I minus 3j minus 2k, and then we need to find u negative 1 square plus 3 square plus 2 square and square root, so we get negative 14. Right. Oh, any for this is quite difficult. So we have this. Letter operation of by a component. Properties of vector, product of two vector. So I stop. Okay, let's go. Okay, direction angle and direction cosine. So as we can see here, we have 3D, three-dimensional. So we have an angle between x-axis to the P point, OP. So alpha is an angle for x-axis and between axis and OP. Okay, alpha. For gamma is y-axis, gamma is z-axis, and OP. Beta from y-axis and OP. Okay, we have this. So determine angle for OPs. Direction. Okay, so cos gamma, cos alpha, cos beta, cos gamma. Direction of cosine of a vector OP defined by this formula. Okay, which is the angle is less than 180 degree. Okay, will be one question from the multiple MCQ from the objective. One question here. Just make sure you can do it. You try lah. You need to try first one. Find a direction cosine and direction angle. So direction cosine and direction angle. So first of all, we need to find the magnitude. So find the magnitude of U. So we have 3, 1, negative 1, 8. So we have square root 74, and the direction cosine we have this thing, and then direction angle. So we need to find the angle. So we have this angle. Okay, boleh? Find the magnitude. After that, combine with find the direction angle, direction cosine, and then later we find the direction angle. Okay, so now operation vector by component. So we have addition, subtraction, multiply with the scalar. So as simple, we can see this operation is simple. So 7, if we have 2 vector, we add. So in general we have, for example, we have x1, x2, y1, z1. So plus x2, y2, Z2. So what we'll have here, we will have x1 plus x2, y1 plus y2, z1 plus z2. If we have three component, so if we have A plus B plus C, so equals to x1, y1, z1 plus x2, y2, z2, so equals plus x3, y3, z3, so equals to x1 plus x2 plus x3, y1 plus y2 plus y3, and then z1 plus z2 plus z3. So if minus, so we minus the element and so on lah. So as easy as that. Okay, if minus, we put a minus one. Okay, next, properties of vector. So if we have properties is behavior lah, perangai dia. Perangai vektor ni apa? A plus B equals to B plus A. Okay, when T is a scalar. But A minus B not equals to B minus A. Okay, make sure this is positive, all positive. And then second, if we add two, we have three vector, we add B plus C, and then we add A plus B is equals to A plus B first. So we can add anything first. So it's okay. So number 3, we add with 0. This is identity for the addition operation. So A plus 0 equals to 0 plus A equals to A. So if A minus A, so A minus A equals to 0. Okay, so KA plus B equals to KA plus KB, and then KTB T is a scalar. Scalar mean a numbers. So KT, we have two scalar here, so KTB 0C, so 0, 1A, negative B. Okay, nothing much, but this for our information. Okay, next is for product of two vectors. So product of two vector, we set that as a dot product a scalar. For two vector, so we will get a scalar. Okay. Product of two vector is a scalar. Scalar meaning a number. Numbers. For example, we have A negative 2, 3, 1 and B 4, 6, B, and find A dot B. So A dot B equals to A dot B equals to A dot B equals to, okay, negative 2 times 4 plus 3, 6 plus 1, 8. So we will get 18. Okay. So that's why we start with a component, 3 component, but we end with a number. So we call it as a scalar. Okay, it's a scalar. A scalar. Alright. So if 3a dot a plus b, so first of all we find what is 3a. What is 3a? And then a plus 4b. What is a plus 4b? We find everything first, and then later on we take this answer, and this answer, we dot product of this answer. So we will get, so this answer we will have negative 6, 9, 3. So here we will have 14, 27, 33. So after we process this, we get this, and then we dot product. So we dot product 3a dot bracket a plus 4b. So we will get negative 6, 14 plus 9, 27 plus 3, 3. Okay, so we get 2, 5, 8. Alright, you can try at your home. And for our attendance today, we find out this angle. If theta is an angle between a vector a dot b, so we have this. So the angle of this AB, we can find the angle of theta by using this dot product. Okay, so we have these two vector, so we have angle. So first of all, we find the a dot b. We got 18, magnitude of a 14, magnitude of b a 116. And then from theorem 1, from this theorem, so we will have this thing. Okay, and therefore to find the theta, we cos everything here, so we get 63/47. Okay, for our attendance today, please find the angle of this vector as usual, and put it at your Padlet. Okay.